Not every space mission begins with confidence, and this one carried questions long before launch day arrived.
Long before liftoff, engineers understood this flight would test assumptions that could not be simulated on Earth.
Only after those questions did preparations move forward toward the launch pad itself.
When people are involved, uncertainty becomes more than data. It becomes responsibility. As daylight reached the pad, the spacecraft stood ready, unchanged in form, but increasingly active inside. Fueling and system activation progressed methodically, transforming a static structure into an operational vehicle.
Inside the capsule, the crew completed final checks, relying on training rather than expectation.
As the countdown approached 0, nothing about the scene suggested how critical the next seconds would be.
At ignition, engines reached full power while the spacecraft remained secured to the launch structure.
With all systems stable, the spacecraft lifted from the ground and began its ascent.
For several seconds, sensors confirmed stability before the vehicle was allowed to move.
Seconds after liftoff, the vehicle cleared the tower and continued upward without deviation.
As ascent continued, the vehicle followed its planned trajectory, leaving the launch site behind.
As the vehicle climbed higher, aerodynamic forces increased and demanded precise control. This phase placed the greatest stress on the vehicle, testing both structure and guidance systems.
As atmospheric resistance faded, the spacecraft transitioned toward a quieter, thinner environment. With fuel expended, the first stage separated, allowing the mission to continue efficiently.
With ascent complete, the vehicle entered a brief coast phase on its path toward orbit.
A brief engine burn adjusted the spacecraft's speed, placing it precisely into its planned orbit.
Once in orbit, motion stabilized and the spacecraft transitioned into routine operational mode.
Following orbit insertion, the crew began systematic checks to confirm vehicle performance.
Amid otherwise normal readings, one small deviation began to draw careful attention.
The live feed on Channel 4 is spiking above the reference threshold.
Confirmed. The delta is outside acceptable parameters. Cross-referencing the reference tables now.
The crew independently reviewed onboard data to confirm what ground controllers were seeing.
At that moment, the anomaly posed no immediate threat to the vehicle or the crew.
Attention focused on a small propulsion subsystem, critical for future maneuvering and docking.
With caution, the mission continued, while engineers gathered more information before committing to the next phase.
The approach trajectory is stable, right within the parameters we projected.
Confirmed. The burn sequence initiated exactly on time.
Ahead, the station came into view, still distant, still requiring careful navigation.
With the plan in place, the first controlled maneuver gently reduced the distance between vehicles.
A conservative approach was selected, prioritizing control and safety over speed or efficiency.
The revised plan was shared with the crew, ensuring every step was clearly understood. As the distance closed, every movement was deliberately small and carefully measured. Inside the cockpit, attention narrowed as automated guidance gave way to closer human oversight.
At a planned hold point, Motion paused while data was reviewed one final time. After careful review, the approach resumed under tighter limits and increased awareness. At close range, acceptable margins narrowed, leaving little room for unexpected behavior. Entering the final approach corridor, the spacecraft aligned itself with careful precision. At the final hold point, motion paused while the last checks were completed. With clearance granted, the spacecraft began its final, carefully controlled movement. Contact was gentle, marking the moment when two independent vehicles became one connected system.
Pressure stable, Commander. Seal integrity confirmed across all ports.
Acknowledged. We are secure.
With pressure equalized, the interface was prepared for the next step of integration.
Analysis suggested the issue could complicate future maneuvers, especially during departure from orbit.
The stabilization metrics are still fluctuating during the final approach.
Check the propellant mixture ratio on engine 3.
It seems consistent with the previous burn profile.
Check these atmospheric readings from the last cycle.
Looks nominal. Confirming the data now.
Daily routines replaced timelines as the crew adapted to an open-ended schedule.
Orbit after orbit passed, offering time to observe and reconsider every assumption.
The structural integrity around the coupling joint is showing stress at 4,000 cycles.
I'm rerunning the thermal load test now.
In space, patience became the safest choice while answers slowly took shape.
We need to review the structural integrity assessments immediately. This spike is unacceptable.
My team is running the numbers, but the localized stress appears critical.
With priorities adjusted, the mission transitioned from a test flight into a period of extended operation. In the end, safety outweighed schedules, reinforcing the principle guiding every human spaceflight.
The review concluded that an immediate return carried more uncertainty than waiting for clearer answers. Rather than wait idly, the crew used the extra time to support ongoing work aboard the station.
Information gathered in orbit flowed continuously to teams on Earth, narrowing remaining uncertainties. Information gathered in orbit flowed continuously to teams on Earth, narrowing remaining uncertainties.
This red bar here clearly indicates a bottleneck in Q3.
Agreed. We need to implement the new process flow immediately to mitigate that risk.
Though delayed, the mission contributed knowledge that would shape future flights.
In spaceflight, success is often defined not by speed, but by decisions made under uncertainty.
The revised timeline for Phase 2 looks achievable.
What about the resource allocation for the accelerated return scenario?
We've accounted for that in the update.
Yeah.
It looks solid now.
Step by step, confidence returned as evidence replaced assumptions.
Aboard the station, preparation resumed without urgency, guided by clarity rather than pressure.
Throughout the delay, the spacecraft performed exactly as designed. When the decision came, it was deliberate, measured, and free of urgency.
With this finalized, we can begin the outreach on schedule.
It's ambitious, but achievable. I support this plan completely.
Progress in space is rarely immediate, but it is always cumulative.
Sometimes, the most successful missions are the quietest ones.
The mission's true return would be measured in knowledge, not immediacy.
Its purpose was never speed, but understanding, caution, and preparation.
This mission did not follow its original timeline, but it honored its purpose. The knowledge gained would quietly shape missions yet to come. In space, progress is measured not by speed, but by the care taken along the way.
Sometimes, the safest decision becomes the most meaningful outcome.